Hello everyone. The title of this video is Solve Quadratic Equations Using the Quadratic Formula. And all the exercises I'm going to be doing in this video are taken directly from a free online textbook at openstacks.org. And it's their Intermediate Algebra 2nd edition text. I'm in section 9.3, titled Solve Quadratic Equations Using the Quadratic Formula, and I'll be working under the heading of the same name. Now I'm only going to be working on the exercises that are even numbered, so numbers 114, 116, 118, all the way down to number 144. You may notice that the odd numbered problems, have links on them. You can click on those links and see the solutions to those problems in the text. So I'm going to be doing the ones, the even ones that don't have solutions posted in the text. I will also have timestamps for each of these questions in the description of the video below. So example 1's timestamp will be for number 114. Example 2's timestamp will be for number 116, and so on up until number 144. So if you'd like to see a specific question, just count down the even numbered problems to see what example number that would be, and then click on that timestamp in the description. And one thing I would request of you also is that when I bring up a new question in the video, pause it and try to work it out yourself first before seeing how I do it and then comparing. Right, because if you're just watching me do these questions without practicing yourself, chances are you're not learning all that much. Right, so the first question is exercise 114, which I have written out here. So you see example 1, number 114. And we are asked to solve each quadratic equation by using the quadratic formula. So I want to talk about that first. What is the quadratic formula? And how do we use it to solve an equation? So suppose we're given an equation of the following form. So a times x squared plus b times x plus c equals 0. Right? And what you're going to notice is that in order to use the quadratic formula, the equation you're looking at has to be in this form. If it's not in this form, then you can't use the quadratic formula. I'll write that out later. So what I'm going to do is I'm going to solve this general quadratic equation here. I'm going to solve it by completing the square. Alright, you have seen this before in previous videos. If not, please refresh your memory on what it means to solve a quadratic equation by completing the square. I'm going to solve this by completing the square method, and let's see what happens. Alright. So remember, the complete the square method was, first you get the quadratic term and the linear term on its own side. So I'd subtract c. So we have a times x squared plus b times x equals, and then subtract c, so that then there's minus c over here on the right side. Right, then you want the and now that I have the quadratic term and the linear term on their own side, I need the quadratic term to have a coefficient of 1. So as long as a is not 1, I'm in trouble, right? I need to then it's very easy to change it to 1 though. Just divide everything by a. So if I divide every term both sides by a, we'll have x squared plus then b over a times x. And then now that I have the coefficient of x squared is 1, I'm going to leave a little space so I can complete the square. Equals, and then negative c over a. Right, now comes the completing the square part. And I'm assuming you remember how to do that. Half of b over a, half the linear coefficient would be b over 2a. Right, b over 2a. But then you square that. B over 2a squared would be b squared over 4a squared, right? B times b, 2a times 2a. And I add this to both sides. Right? So I'm adding b squared over 4a squared to both sides. Now this addition of b squared over 4a squared changes the expression on the left into a perfect square trinomial. Right, this x squared plus b over a times x plus b squared over 4a squared. This can be expressed as a binomial to the second power. And that binomial is the variable plus, whatever half the linear coefficient was, which was b over 2a. And you can check this. Take x plus b over 2a and square it. Right? X plus b over 2a times x plus b over 2a again in FOIL and combine like terms and simplify. You'd end up with x squared plus b over a times x plus b squared over 4a squared. Alright, then this expression on the right side, need a common denominator. Now I have b squared over 4a squared. Alright, I'm just going to put that first because it has a positive. It's positive. The second fraction, though, I need to multiply the numerator and denominator by 4a to get a common denominator of 4a squared. So then we'd have minus 4ac over 4a squared, right? This is the same thing as minus c over a, but I multiply the top and bottom by 4a. Now I have a common denominator of 4a squared, and the numerator is b squared minus 4ac. Right. Now I apply the square root property, which again I'm assuming you know. If this squared is this number, that means that x plus b over 2a is either going to be positive or negative. Right? Usually I write them separately, but for right now I'll write them at the same time. This x plus b over 2a is either positive or negative the square root of this number, which if I apply the quotient property, the square root of the numerator is the square root of b squared minus 4ac divided by, and the square root of 4a squared would be 2a. Right. So again, make sure this fraction bar is big enough so that you know that the 2a is not inside the radical. And then finally, to get x alone, find the solutions. I'd subtract b over 2a. Right, so x is equal to negative b over 2a plus or minus, right? One with the plus, one with the minus. This is technically two solutions here. And then the square root of b squared minus 4ac, and then all that, right, divided by 2a. And then we can put these together because they have the same denominator, right? They both have a denominator of 2a. So then finally, we can write the solutions of this equation in this way. We have this common denominator of 2a, right? So I just put everything over 2a and combine the numerators. We have negative b plus the square root of b squared minus 4ac all over 2a, and negative b minus for the other solution. Negative b minus the square root of b squared minus 4ac, all of that divided by 2a. And this is it. This is called the quadratic formula. Now I know there were a lot of letters there, but the procedure I went through was that completing the square procedure, because you can use completing the square method to solve any quadratic equation. But yeah, so this is what we're going to need, right? That's what they're asking us to use to solve the equations we're given. Now notice how I ended up with this, but I started with this equation here, right? ax squared plus bx plus c equals 0. So the equation must be in this form, right? The equation you're looking at must be in this form to use the quadratic formula. If the equation does not look like this, where everything's on one side, 0 on the other, ax squared plus bx plus c equals 0, then you can't use the quadratic formula. Quadratic formula. That's what I meant. Right? So equation must be in this form to start, and then you find out what a, b, and c are, and plug them into the formula and simplify, and you'll get your two solutions. Okay. All right, so I'm going to be writing this out quite a bit. So first, we get it in this form. Identify a, b, and c. Right, a is the quadratic coefficient, b is the linear coefficient, c is the constant term. And then I substitute those into the formula and simplify. All right, and state your two solutions. Okay? All right. So in question 1, I'm going to show you, you don't have to remember, I know they say use the quadratic formula. You can always solve, right? You can always solve by completing the square. You don't have to use the quadratic formula. Right, so this first one I'm going to do in 2 ways, and then the rest of them I'll use the quadratic formula for. But you can always solve quadratic equations by completing the square. Right. So just keep that in mind. Right. So I'll do it in 2 ways. So first, by completing the square. So number 1, exercise 114 in the text there. I got 4n squared minus 9n plus 5 equals 0. So that's in the ax squared plus bx plus c form, but instead of x, it's n. Right, no big deal. So I could use the quadratic formula right now. Right, the equation is in this form. Right. But before I do that, let's do completing the square. Right. And I'll show you that you can do completing the square, or you can do the quadratic formula, and you end up with the same solutions. So you choose which one you like better. So you have the quadratic term and the linear term. I want to get these on their own side if I'm solving by completing the square. So I'm going to subtract 5 first. So we have 4n squared minus 9n equals negative 5. And then I want the quadratic term to have a coefficient of 1. So I divide everything by 4. So we have n squared minus 9/4 times n. Now I can complete the square over here because the quadratic term is a coefficient of 1. So I'm going to leave some space. Equals negative 5/4. Right. Then I complete the square. Now half of negative 9/4 would be negative 9/8. Negative 9 over 8. And then squaring that would be 81/64. Right? 9 squared and 8 squared. 81/64. And I add that to this other side as well. Right. So now the left side is the quantity n minus 9/8 squared equals, and then over here, getting a common denominator, I'd have to multiply 4 by 16, and then 5 by 16, that's negative 80, right? Negative 80 over 81 over 64, right? Multiplying 5 by 16 and 4 by 16, plus 81/64. Putting these together gives me positive 1/64. And then applying the square root property, n minus 9/8 must either be positive or negative, right? And you can write them separately if you wish. The square root of 1/64, which would be 1/8. and then I would add 9/8 to both sides. Let me take this up here. Sorry about the arrows and all that. So n equals, positive 9/8 plus or minus 1/8, which, since these have the same denominator, you can put them together. This is all over 8, and we have 9 plus or minus 1. So the two solutions are this: 9 plus 1, which is 10 over 8, which would be 5/4, or 9 minus 1, which is 8 over 8, which is 1. And then don't forget to check your solutions. Always check your solutions, back in the original equation. Now, I'll leave that to you. All right, you can plug these in for the variable n and see that it works. So this is a solution, this is a solution. All right, so that was by completing the square, right? This was by completing the square, this method here. Now, let me show you that you can leave the equation the way it was and solve using the quadratic formula. All right? And once again, the equation has to look like this, where quadratic plus linear plus constant term on one side equals 0 on the other. It's got to be 0 on the other. Right? And then I can use the quadratic formula. So let me do that again. All right? Same question. Remember that the solutions were 5/4 and 1. You're going to see that we get the same solutions using the quadratic formula. So this is in the form, right, this equation is in the form a times n squared plus b times n plus c equals 0. So we can use the quadratic formula. Right. So the quadratic formula would be, the solutions are n equals instead of x, right? It's just n instead of x. The opposite of b plus or minus, right? One with the plus, one with the minus. The square root of b squared minus 4ac, and then all of this divided by 2 times a, where a is the quadratic coefficient, so a is 4. B is the linear coefficient, so -9, don't forget negatives. And C is the constant term, which is +5. All right, so I'm going to substitute these into the formula and then simplify. And we should end up with 5/4 and 1 as the two solutions to this equation. All right, let's see. So we have the opposite of b, right? So the opposite of -9, which will end up being +9, plus or minus the square root of b squared, so -9 squared, which will be +81, minus 4 times a, so times 4, times c, right, times 5. All that in the square root there, right? The b squared minus 4ac is all in the square root symbol. And then all of this, right, everything, divided by 2 times a, divided by 2 times 4. And then we simplify. Now the first term up here, negative, the opposite of -9 is +9, plus or minus the square root of -9 squared is 81, minus, and then 4 times 4 times 5 is 80. All this divided by, and then 2 times 4 is 8. And I hope you see that this is just the square root of 1, which is 1. So we end up with 9 plus or minus 1 divided by 8, which gives me the two solutions. N equals 9 plus 1, 10 divided by 8, which is 5/4. And n equals 9 minus 1 is 8 divided by 8, which is 1. And I get the exact same solutions that I got earlier using the complete the square method, right? 5/4 and 1, 5/4 and 1, right? After simplifying using the quadratic formula. So like I said at the beginning of the problem, it's up to you. You can solve by completing the square or using the quadratic formula. They give you the same result. Alright, now the rest of the video though, I'm going to use the quadratic formula because that's what they asked us to do. Alright, so for the rest of the video, I'm using the quadratic formula. So remember, the first step is to get it in that particular form. Alright, so next question, example 2, exercise 116. Now, this is already in that form. Right? This is in the form a times q squared plus b times q plus c equals 0. Right? It's a quadratic term plus linear term plus constant term equals 0. So we can use the quadratic formula to state the solutions. So again, that would be q equals, right, because the variable's q, the opposite of b plus or minus the square root of b squared minus 4ac, all of this divided by 2a, right? Where a equals 3, right, the coefficient of the q squared, b equals positive 8, the coefficient of q to the first, and c equals negative 3, right? Don't forget the negatives. The constant term here is negative 3. Alright, so I'm going to substitute these values into the formula and we'll simplify and have our solutions. So q equals, the opposite of 8, so this is negative 8, plus or minus the square root of 8 squared minus 4 times 3 times negative 3, right, 4ac, and then all of this divided by 2 times a. Right. Alright, so this is negative 8 plus or minus the square root of 64. And then we have a negative times a negative here, so this can be a positive. Right, negative times negative will be positive, and then 4 times 3 is 12, 12 times 3 is 36. And then divided by 6, right, 2 times 3. So this is negative 8 plus or minus 10, right? This is the square root of 100. 64 plus 36. So we have negative 8 plus or minus 10 divided by 6. And we can get our two solutions. One of them, negative 8 plus 10 is 2 divided by 6. 2 6 is 1/3. Right? So q equals 1/3 is a solution. The other one, negative 8 minus 10, that's negative 18 divided by 6 is negative 3. Right, negative 18 divided by 6 is negative 3. And there you go. And then don't forget to check them. Right, don't forget to check them, but I promise you, if you did everything correctly, these should be good. Right. So plug in 1/3 for q, plug in negative 3 for q, and see that you get the correct result. 0 equals 0, that you get a true statement. Okay. Next question. So example 3, exercise 118. It's in the form I want. Right? It's in the form I want. The value of a would be 1. The value of b, the linear coefficient, would be positive 3. And the value of c, the constant term, is negative 18. And it's in that standard form that I wish, aq squared plus bq plus c equals 0. So I can use the quadratic formula. And once again, I'll write it out. I'm going to write it out for every single problem. Right? So you can't help but memorize it. Hopefully, I would recommend you memorize it just to make things a little faster. So remember, it's the opposite of b plus or minus the square root of b squared minus 4ac, and then all of that divided by 2a. Alright, and we substitute these values. So we have negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 18. Then all of this divided by 2 times 1. So that's negative 3 plus or minus the square root of 9. And then again we have a positive. Negative times negative would be positive. And then really we just have 4 times 18, which would be 72. 40 plus 32, 72. All this divided by 2. And that's negative 3 plus or minus the square root of 81. All divided by 2. That's negative 3 plus or minus, 9 divided by 2. And now I can state the solutions. Q equals, negative 3 plus 9 is 6, divided by 2 is 3. So 3 is a solution. Or negative 3 minus 9, that's negative 12. Then divided by 2 would be negative 6. And again, once you've got the solutions, check them. But I'm telling you right now, if you did everything correctly, they should work. But check them back in the original equation. Wonderful. Alright, so far, questions 1 through 3, the equation was already in the form that I wanted, where everything was on one side, 0 on the other, right? A quadratic term plus a linear term plus a constant term equals 0. Well, in number 4, exercise 120 from the text, that is not the case. All right, this is not in the form that I want to be able to use. I could solve by completing the square pretty easily here, but this is not in the form, a times t squared plus b times t plus c equals 0. So that means I can't use the quadratic formula yet, right? We can't use the quadratic formula yet. Emphasis on yet, right? Because all I need to do is add 40, right? Just get t squared plus 13t plus 40 equals 0. This is the form we want in order to be able to use the quadratic formula. All right, everything on one side, 0 on the other. All right, once that's the case, we identify our a, b, and c, right? A is 1, 1t squared. B is 13. And c is positive 40, right? And now we can just jump straight to the solutions, straight to the formula. T equals, again I'll write it out, the opposite of b plus or minus the square root of b squared minus 4ac, all this divided by 2a. Alright, so the opposite of b, negative 13 plus or minus the square root of b squared, 13 squared, minus 4 times a, right, times 1 times c times 40. And then all this divided by 2 times 1. Right? So this is negative 13 plus or minus the square root. 13 squared is 169. Minus, and then 4 times 1 times 40 is 160. All that divided by 2. And we're getting negative 13 plus or minus the square root of 9, so plus or minus 3. Right? 169 minus 160 would be 9. So square root of 9 is 3, divided by 2, and then we can get our two solutions. One of those is with the plus, right? Negative 13 plus 3 would be negative 10, divided by 2 would be negative 5. Right, and then negative 13 minus 3 would be negative 16, divided by 2 would be negative 8. So the solutions are negative 5 and negative 8. And they should work. And again, please check them out. Right. Fantastic. All right. Next question. But again, like I think for some of these, they'll be in the form we want right away, and some other ones we have to put into the form that we want, right? Where again we have a quadratic term, linear term, constant term, all on one side and 0 on the other. All right, next question. Same number 5, exercise 122 from the text. Now this is already the way I want it. Quadratic plus linear plus constant equals 0. Wonderful. So I'll identify the coefficients. A is 2. The B is 8. And the C is 5. Right. Great. And then P, we can jump straight to the quadratic formula now. P equals negative b, plus or minus the square root of b squared minus 4ac, all of this divided by 2a. Then we just substitute, right? So we have negative b, negative 8, plus or minus the square root of 8 squared minus 4 times 2 times 5. All this divided by 2 times 2. This is negative 8 plus or minus, now this is 64. I'm just going to do this out loud. 64 minus 40, so 24, square root of 24, and then all this divided by 4. Now the square root of 24 isn't nice, right? It's not a perfect square, but it can be simplified. Right? This is negative 8 plus or minus. The square root of 24 is the square root of 4 times the square root of 6, so 2 times the square root of 6. And then if we just divide each term by 4 and simplify, we get the following. Negative 2, right? Negative 8 divided by 4, plus or minus, and then 2 times the square root of 6 divided by 4. 2 goes into 4 twice. So we'd have the square root of 6 divided by 2. All right, so my two solutions here, one of them is p equals negative 2 plus half the square root of 6, right? The square root of 6 divided by 2. And the other one is negative 2 minus the square root of 6 divided by 2. Right? And these should work, right? You can use a calculator or do it by hand, but plug these into the equation for p and they should satisfy it. Great. I'll leave it to you to check. All right, next question. All right, so got to be a little careful here because you see there's a variable b, but then I'm also going to have a constant b. Pardon me. Now this is already in the form that I want. Right, a quadratic term plus a linear term plus a constant term equals 0. So we identify the coefficients, right? A equals 5. B equals, now be careful, this b is not the same as the variable b. Right? It's just a coefficient, 2, a linear coefficient. And c equals negative 4. Right? So then b equals, right, again, this is the variable b, not the constant b, right? This is the constant b over here. This is always 2, whereas this changes. The opposite of b, right, the constant b, plus or minus the square root of b squared minus 4ac, all of this divided by 2a. Okay, so the opposite of 2, plus or minus the square root of 2 squared minus 4 times 5 times negative 4, all that divided by 2 times 5. Alright, so this would be negative 2 plus or minus the square root. Now this is 4, and then here we have a negative times a positive times a negative, so it's plus. That's 84. 4 plus 80, right? 20 times 4 is 80. 4 plus 80, that's the square root of 84. And then all this divided by 10. Now the square root of 84, 84 is 4 times 21. So we can break this up to negative 2 plus or minus 2 times the square root of 21. And then all that divided by 10. And then I'll just divide each term by 10 like last time. So this is negative 1/5. right? Negative 2 divided by 10, plus or minus 1/5 times the square root of 21, or the square root of 21 divided by 5. Right? Or you could keep it all over 5 if you want. You know, they both have the same denominator. So my solutions here are, b equals negative 1/5 plus the square root of 21 divided by 5. And the other solution would be negative 1/5 minus the square root of 21 divided by 5. And once again, I leave it to you to check that these are in fact solutions to this equation. Okay. Okay. Next question. Same stuff. I'm doing the same thing every time, just making sure the equation we have, the quadratic equation we have, is in that form where, you have a quadratic term, linear term, and constant term added up on one side and 0 on the other, which this one is. So now I can jump into the quadratic formula where a is 1, b is positive 4, the linear coefficient, and c is the constant term, negative 4. So jumping right to the solutions, y equals the opposite of b plus or minus the square root of b squared minus 4ac, all that divided by 2a. So the opposite of b would be negative 4 plus or minus the square root of, b squared, 4 squared minus 4 times a times c, 4 times 1 times negative 4, all this divided by 2 times a, right, 2 times 1. So that's negative 4 plus or minus, now 4 squared is 16, and this is negative 4 times 1 times negative 4, that's plus 16. 16 plus 16, that'd be the square root of 32. All divided by 2, right, 2 times 1. And the square root of 32 can simplify as the square root of 16 times the square root of 2, or 4 root 2. So this is negative 4 plus or minus 4 times the square root of 2. And then divide each term by 2. Negative 4 divided by 2 is negative 2. You got plus or minus, and then 4 divided by 2 is 2 again, so 2 times the square root of 2. And we get our two solutions. One of them is y equals negative 2 plus 2 times the square root of 2. And the other solution is negative 2 minus 2 times the square root of 2. And there you go. And again, I leave it to you to check that these are indeed solutions of this equation. Wonderful. All right, next question. Now, it's already in the form I want. 6x, the quadratic term plus a linear term plus a constant term equals 0. But one thing I'm noticing is that every coefficient is even, right? Every coefficient has a common factor of 2. So before I even get started with the quadratic formula, I want to make the numbers a little smaller. So I'm going to divide by 2 on both sides. That'll give me 3x squared plus 1x minus 10 equals 0. All right, these are the same equation. They're equivalent equations. They have the same solutions. Right? The only difference is these coefficients are smaller. And I'd rather work with this second equation with the smaller numbers. Right? All right, so now I can use the quadratic formula. Right? A for this one is positive 3. B is positive 1. And C is negative 10. Alright, now if you didn't do that, if you didn't divide by 2, and you use 6, 2, and negative 20, after you're done simplifying, you're going to end up with the same solutions as if I did divide by 2 first. Right, so if you don't see it, that's fine. As long as you know how to use the quadratic formula and simplify, you'll be good. Alright, so the solutions of this equation are x equals, again, I'll write the formula again, negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Negative b is, negative 1 plus or minus the square root of 1 squared, b squared, minus 4 times 3 times negative 10, right, 4ac. all of that divided by 2a, right? 2 times 3. And we got negative 1 plus or minus. Now this is 1 plus 120. Right? Negative 4 times positive 3 times negative 10 would be positive 120. So that's 11, right? 1 plus 120 would be 121. The square root of 121 is 11 divided by 6. And I can get my solutions from this. So one of them, negative 1 plus 11 would be 10/6, or 5/3. And the other solution, negative 1 minus 11 is negative 12 divided by 6 is negative 2. All right, now again, I leave it to you to check these solutions, right? 5/3 and negative 2. And like I said, you would get the exact same solutions if you kept 6, 2, and negative 20 as your A, B, and C. Right? I promise you that, and you can check that if you want. It's just I like to do that, though. If I notice, if you can multiply or divide both sides by some number to make the numbers easier to work with, you know, I like doing that straight away. All right. Next question. Example 9, number 130 from the text. It's already in the form that I want. So the value of A is 2, the value of B is negative 1, right, and the value of C is positive 1. So we can jump straight to the solutions, quadratic formula. The opposite of B plus or minus the square root of B squared minus 4AC, and then all this divided by 2A. Now, B is negative 1, so the opposite of B will be positive 1. So positive 1 plus or minus B squared, you know, negative 1 squared is 1. I'm just going to write the square now. Minus, and then 4AC, 4 times 2 times 1 is 8. Divided by 2 times A is 4. Right? 2 times 2. I'm just kind of simplifying things as we go. So this is 1 plus or minus the square root of negative 7 divided by 4. Right? All that divided by 4. Well, wait a minute. Square root of a negative. Remember, the square root of a negative number is imaginary, right? It's not a real number, not a non-real number. We're going to rewrite this with that I, right? This is the square root of positive 7 times I, where don't forget that I is the square root of negative 1. So that's how I'm going to rewrite this. So we have 1 plus or minus, and then the square root of negative 7 I'm rewriting as the square root of 7 times I. And then these are getting divided by 4. Right? And I'm going to do that. I'm going to divide each of those by 4. So one solution is 1/4 plus the square root of 7 divided by 4 times I. And the other solution is 1/4 minus the square root of 7 divided by 4 times I. Right? And there are your two complex solutions with an imaginary part. Now every number is complex. It's just these these are complex with an imaginary number attached, right? With an imaginary number part. And once again, I leave it to you to check that those are indeed solutions of this equation. All right. Next question. So again, this is already set up the way I want. Quadratic plus linear plus constant equals 0. So I can jump right to the quadratic formula to state the solution. So the value of A here is 8. The value of B is negative 4. The value of C is positive 1. All right, and the solutions are the opposite of B, plus or minus the square root of B squared minus 4AC, all this divided by 2A. All right, B is negative 4. So the opposite of B would be positive 4, and plus or minus the square root of, and then B squared would be positive 16, and then 4AC would be 32. 4 times 8 times 1, that's 32, minus 32. Divided by 2 times A, 2 times 8 is 16. So this is 4 plus or minus the square root of negative 16 divided by 16. the square root of negative 16 is 4i. Right, it's imaginary. This is the square root of 16 times I. So we have 4 plus or minus 4i. And then divide each of these by 16. So that'd be 1/4 plus or minus 1/4 I. Right, dividing each of those terms by 16 and simplifying. So my two solutions here, one of them is x equals 1/4 plus 1/4 I. The other one is x equals 1/4 minus 1/4 I. And there you go. Again, two complex solutions that have an imaginary number, an imaginary term. Fantastic. All right, next question. All right, so here's one where it's definitely not in the form that I need it to be in. All right. So I need to multiply this out and get everything to one side. So you have x plus 1 times x minus 3. That'd be x squared minus 2x minus 3. Right, when you multiply those in FOIL and combine like terms, equals 2. Still not in that form yet. I got a quadratic, a linear, and a constant term added up over here, but the other side is 2. It's not 0. So I need to subtract 2. And now I have x squared minus 2x minus 5 equals 0. Now I'm in the form that I want. Now I can identify that a, b, and c. A is 1, b is negative 2, and c is negative 5. Right? And now that I'm in that form, I can jump to the solutions in the quadratic formula. Right? X equals the opposite of b plus or minus the square root of b squared minus 4ac, all this divided by 2a. Alright, so the opposite of b would be positive 2 plus or minus the square root. B squared would be positive 4, and then minus 4 times a times c. Well, negative 4 times 1 is negative 4 times negative 5 would be plus 20. Right, minus 4ac would be positive 20. And then divided by 2 times a is 2. Right, 2 times 1. So we have 2 plus or minus. Now this is the square root of 24, which is 2 times the square root of 6. Right. Square root of 24 simplifies to 2 times the square root of 6. And then dividing each of these by 2, 2 divided by 2 is 1, plus or minus, and then the 2's cancel in the next term as well. You just got the square root of 6. So my two solutions are 1 plus the square root of 6 and 1 minus the square root of 6. Right? And I leave it to you to check that these are indeed solutions of this equation. Okay, great. Next question. Same deal as number 11. Right? This is definitely not in the form that I need it to be in order to be able to use the quadratic formula. So I need to put it in that form. So I'm going to multiply this left side out. X plus 2 times x plus 6 would be x squared plus 8x plus 12. Right. Equals 21, right? And now I need 0 on this side. So I'm going to subtract 21. Right? So that's x squared plus 8x, and then 12 minus 21 is minus 9. Right, negative 9. And then equals 0. Right. Now yes, you may recognize, hey, this is factorable, but we're going to use the quadratic formula. Now that it's in this form, I can use the a, b, and c and jump to the solutions in the quadratic formula. A is 1, b is positive 8, the linear coefficient, and c is the constant term, negative 9. And the solutions take on this form, the opposite of b plus or minus the square root of b squared minus 4ac, all of this divided by 2a. b is 8, right? So this is negative 8 plus or minus the square root of 64, right? 8 squared. Then minus 4ac, minus 4 times 1 is minus 4, times negative 9 is positive 36, right? And divided by 2a is 2. 2 times 1. So this is negative 8 plus or minus 10. This is the square root of 100. 64 plus 36 is 100. Square root of 100 is 10. All divided by 2. So this is negative 4, plus or minus 5, right? Dividing each of those by 2. So my solutions here, one of them is negative 4 plus 5, which is positive 1. The other one is negative 4 minus 5, which is negative 9. Right, so the solutions are 1 and negative 9. And again, I leave it to you to... Oh, this would be easy to check, right? If I plug in 1, you get 3 times 7 is 21. That's true. Plug in negative 9, you get negative 7 times negative 3 is positive 21. That's true, right? That's an easy one to check by hand. Wonderful. All right, next question. All right, so now we got some coefficients that are fractions. Now it's not in the form I want, right? I want everything on one side, 0 on the other. So the first thing I'll do, you have 1/3 n squared plus n, and then I'm going to add the half plus a half equals 0. Now this is great. I mean, this is in the form that I want. an squared plus bn plus c, where a is 1/3, b is 1, and c is 1/2. You can do that. You can use a is 1/3, b is 1, c is 1/2, and then plug those into the quadratic formula and try simplifying. It's just, I know people don't like working with fractions all that much. So we can let's clear the fractions. Now I hope you recall how to clear fractions in an equation. I'm going to multiply by 6, right? That's the LCD, right? The least common denominator. And I'll make that little note here. Right, this is the LCD, right? The least common denominator. So if I multiply everything by 6, now 1/3 times 6 is 2, so you'd have 2n squared plus 6 times n plus, and then half of 6 is 3. Right, and there's an equation that's a little nicer looking because the coefficients aren't fractions. And now I'm going to use the quadratic formula, right? A is 2, B is 6, and C is 3. Right? And we have n equals, negative b plus or minus the square root of b squared minus 4ac, all that divided by 2a. Negative b would be negative 6, right? Plus or minus the square root. 6 squared, b squared, that's 36. Minus 4ac, minus 4 times 2 is minus 8. Times 3 would be minus 24. Right? Divided by 2 times a is 4. Right? 2 times 2. So this is negative 6 plus or minus. Now this is the square root of 12. Alright, this would be the square root of 12, which is 2 times the square root of 3 when you simplify it, right? Square root of 4 times square root of 3. And then let's divide each of these by 4. Negative 6 divided by 4 is negative 3/2 when you reduce it, plus or minus, and then 2 times the square root of 3 divided by 4. 2 goes into 4 twice, and you have the square root of 3 divided by 2. Alright, so my two solutions here are n equals negative 3/2 plus the square root of 3 divided by 2, and negative 3/2 minus the square root of 3 divided by 2. Sorry about the clutter on that, but these are the two solutions. And I leave it to you again to check those results. Alright, great. Alright, next question. Same deal. Alright, got some fractions showing up here. Now you can get it in the form that we want, where everything's on one side, zeros on the other. So I can subtract 3 to start. Right, so we have 1/9 times c squared plus 2/3 times c, and then minus 3 equals 0. And this is in the form that I want. It's quadratic plus linear plus constant equals 0. So I could use the quadratic formula where A is 1/9, B is 2/3, and C is -3, and then plug those into the quadratic formula and solve. But again, I feel like people don't like using fractions all that much, so what I'm going to do is I'm going to clear those fractions. The least common denominator would be 9, right? So I'm going to multiply everything by 9. 1/9 times 9 is 1, so you just have C squared, plus, and then 2/3 times 9 would be 6, right, plus 6C, and then minus, and then 3 times 9 is 27. So we're going to solve this equation now, right? No different, right? Multiplying both sides by 9 doesn't change the solutions at all. And now I'm using the quadratic formula where, again, A is 1, the coefficient of the square term, B is +6, and C is -27. Alright, so we have C equals, now be careful, right? Like earlier with the B problem, this is the variable C, whereas this is a constant C. C equals, the opposite of B plus or minus the square root of B squared minus 4AC, where C is -27. All that divided by 2A. B is 6, so this is -6 plus or minus the square root of B squared, which would be 36. Then -4 times A is -4, and then -4 times C. -4 times -27 would be +108. So we have 36 plus 108 in the square root there. Yeah. And then divided by 2 times A. 2 times A is just 2 times 1, that's 2. So that's -6 plus or minus. Now 36 plus 108 is 144. And the square root of 144 is 12. And then dividing each of these by 2, we get -3 plus or minus 6. Right? So the solutions here are, one is -3 plus 6, which is +3. And the other one's -3 minus 6, which is -9. So the two solutions to this equation are +3 and -9. And again, I leave it to you to check, plug those in for C back in the original equation and see if you get a true statement. Great. All right. And the last questions. This is the last page. Example 15, number 142 from the text. Now you may notice, you may recognize this left side. Now this isn't the form that I want, right? This is quadratic plus linear plus constant equals 0. But you may recognize that as a perfect square trinomial. That's actually factoring to 5d minus 6 squared. So the only solution here would be 6/5, right? Because there's only one factor here twice. So I'm going to tell you right now, the only solution, there's only one solution here, 6/5. But we're going to also see that with the quadratic formula, right? A is 25, B is -60, and C is 36. And let's go into the quadratic formula. Right, D equals the opposite of B plus or minus the square root of B squared minus 4AC, all that divided by 2A. Alright, so B is -60, so the opposite of B is +60, plus or minus square root of, now B squared would be 3600, and then minus 4AC. Now -4 times A would be -400. I'm sorry, -100. 4 times 25 is 100. -100 times 36 would be -3600. And look at this. 3600 minus 3600, that's 0. And then 2 times A is 2 times 25, that's 50 in the denominator. So we have 60 plus or minus 0, square root of 0, all over 50. Well, that's just 6/5 plus or minus 0. But adding 0 and subtracting 0 doesn't change anything. So there's only one solution here. And they'd call this a repeated solution because there were two factors of 5d minus 6. But the only solution here is 6/5. Right. So you might notice that that's going to happen when the expression under the square root, the b squared minus 4ac, whenever that's 0, you're going to have just one solution to the equation. We'll talk more about that, how to determine what kinds of solutions and how many using b squared minus 4ac. We're going to talk about that in the next video on something called the discriminant of a quadratic equation. Alright, and then finally, this is the same kind of problem. It's already in the form that I want to use the quadratic formula. But like I said, like in number 15, you may recognize this. You can say, oh, I know how to factor that. That's a perfect square trinomial. That's 4y plus 1 to the second power. And so the only way this is going to happen, the only thing that you can square to get 0 is 0. So this is only happening when 4y plus 1 equals 0, or when y equals negative 1/4. This is going to be the only solution. All right, y equals negative 1/4. But let's see that with the quadratic formula. All right, so a is 16, b is 8, c is 1. And I'm putting these into the quadratic formula since my equation is in that form that I want. Right? So negative b plus or minus the square root of b squared minus 4ac, all this divided by 2a. B is 8, so that's negative 8 plus or minus the square root of 64, right, b squared. And then negative 4ac, well, negative 4 times 16 is negative 64, times 1 is negative 64. And look at that, again, we have 0 inside the square root. And you'll see if we have 0 inside the square root, there's only one solution, because adding 0 and subtracting 0 doesn't change anything. And then 2 times 16 is 32 in the bottom. So I end up with negative 8 plus or minus 0 divided by 32, which would be negative 1/4 plus or minus 0. All right, negative 1/4 plus or minus 0, which changes nothing. So the only solution to this equation is y equals negative 1/4. Wonderful. Right. Great. But yeah, so just to make things a little faster for problems like this, please have the quadratic formula memorized, right? Like I throw back in here. Remember, it's got to start off in this form. Quadratic term plus linear term plus constant equals 0. And then you identify the quadratic coefficient as a, the linear coefficient as b, and the constant term as c. And then you can jump right to the solutions, right to this quadratic formula here, and of course simplify. Great. Alright, so I'm hoping that watching me go through these 16 questions, 16 examples here, help you in some way when you're asked to solve quadratic equations using the quadratic formula on your own. Alright, and thank you very much for watching.